Welcome to AI/KI NodeCraft. Tired of broken workflows? I build energy-efficient AI pipelines that actually work on budget 8GB hardware. If it runs on an old GTX 1080 or Tesla P4, it will run on any modern card as long as your PyTorch version and NVIDIA drivers match your architecture. Stop wasting VRAM and welcome to the lab.
Here is the first part of our unified pipeline, the Z-Image Turbo architecture powered by the Qwen 3 text encoder, running locally in a highly memory-efficient Q6 GGUF quantization. As you can see in our active Ubuntu virtual environment, our production dependencies are pinned to PyTorch 2.5.1 and Transformers 5.9.0, ensuring absolute stability on our 8GB hardware, moving into the ComfyUI grid. Let's look at the generation parameters. After injecting our descriptive prompt, we lock the latent dimensions strictly to 512 by 512 pixels. This native resolution is absolutely crucial because it acts as the exact structural canvas required by the Float Advanced Video Engine in the upcoming step. Our XAMPR is configured to execute a fast, low-step inference pass using the Euler sampler. Now let's cue the prompt and watch the live execution. And there it is. A perfectly generated high-fidelity base frame of Genug, completely tailored for latent motion. Now let's move to the second pillar of our setup, voice creation for Genug. For this we leverage OmniVoice TTS to generate our master audio track. What makes this pipeline incredibly powerful on our 8GB hardware is that the Float Advanced Latent Engine directly analyzes the emotional inflections, tone, and specific pronunciation embedded within the voice file to drive the facial style. Because Float responds organically to these vocal emotions, you need to be careful with your initial Z-image canvas. In special cases, like highly intense or aggressive speech, the latent engine can force extreme jaw movements that might cause visual glitches or texture warping on rigid mechanical parts. If you notice any unnatural glitching during your 780-frame render, the secret is to tweak your initial prompt. Now pay close attention to the voice cloning phase, as this is where the real magic happens. Inject your master voice sample into the reference node and populate the text box with your target script. Crucially, you must audition the reference audio file first to guarantee absolute clarity and a completely clean signal. Remember, any minor background hiss or distortion will be amplified during the cloning pass, directly breaking the fidelity of your final vocal match. Now let's look at a critical production secret that elevates our lip sync quality drastically. Our raw voice file is exactly 21 seconds long. However, instead of feeding it straight into the video engine, we are adding 2.5 seconds of pure silence right at the beginning and another 2.5 seconds at the very end. This scales our final master timeline to exactly 26 seconds. This padding is a vital VFX workflow hack. It acts as an acoustic pre-roll and post-roll, giving the latent engine 5 seconds of total breathing room to stabilize its coordinates. It completely eliminates frame zero mouth glitches, ensures a natural closing animation of the jaw after the final word, and gives you clean handle frames for seamless transitions in your video editing software later. To build this cross-platform setup natively inside ComfyUI, you only need two node types, the empty audio node to generate our silence, and the audio concat node to fuse the tracks sequentially. If these nodes show up red or aren't available in your menu, simply open your ComfyUI Manager, click on Install Custom Nodes, search for ComfyUI Audio Toolkit or Ryan on the inside, and hit Install. It's a clean, zero-effort workaround that secures a flawless 780-frame render on both Windows and Linux. Now we finally move to the ultimate step of our pipeline, sending our Z-image canvas and the newly padded audio file straight through the Float-optimized advanced workflow. This is where the core neural transformation takes place, fusing our acoustic cues and structural layout directly in the latent space to guarantee a highly consistent and fluid output. Thanks to our precise 2.5-second pre-roll and post-roll handles, the engine has the perfect temporal playground to calculate every single frame smoothly, preventing any jarring transitions. Let's hit QGU prompt and watch our 8GB Tesla P4 generate the complete Genug talking avatar sequence in real time. And there she is, a perfectly synchronized high-fidelity cybernetic character, proof that budget hardware can deliver elite-tier VFX outputs without a single compromise. Welcome to the future of NodeCraft.